Hello from Isaac and Noah. They thought maybe you guys needed a review, so they've got the algebra book out here on the table, and they're ready to make sure you guys know how to solve systems of equations. The biggest thing that I want you guys to understand to start is that you've learned or you've gone through 3 different sections, and it's just like when we started learning how to graph equations. There were 4 different methods, and by the end you probably all had a favorite, which one you liked the best. Remember that to graph equations you could have found like 5 different ordered pairs using the t-chart or the table. Then a lot of you picked up on slope-intercept form, then we did point-slope form, and finally we did standard form. Most of you ended up with a favorite. Just like these 3 sections, you're probably going to have a favorite. It's important to remember that all 3 methods work, but depending on the situation, one is going to be better or easier than the others. And part of it is knowing when to use each method. So let's review the 3 ways to solve systems of equations. And if you haven't figured out yet, a system of equation is just more than one equation. So it can be 2, it can be 3, it can be any, but it's at least 2 equations. Okay, section 6.1 is solving systems of equations by graphing. So remember, you have 2 different equations where all you need to do is graph them. And remember, you've learned many tricks throughout the years to manipulate equations to make them easy to work with. And the golden rule, always to remember, is whatever you do to one side, you have to do to the other. So some of you probably like slope-intercept form the best. So I'm going to stick with that one. And I'm going to show you just one way that you can rewrite this equation to get it in slope-intercept form. I am not necessarily a fan of negative y. So if I want to move negative y, I could just move that to the other side. So I would be left with 4x is equal to a positive y minus 1. Well, I really want y by itself, so then I would want to add 1 on both sides. So I get 4x plus 1 is equal to y. And since you have 2 things that are balanced or that are equal, you could simply flip-flop their sides. And so your equation with y on the left side would be y is equal to 4x plus 1. Now it's written in slope-intercept form. Remember that slope-intercept form is y is equal to mx plus b. M, the number in front of your x, is your slope, and your b is your y-intercept. So to graph this equation, it crosses my y at 1, so here is my first point, and my slope is 4, which is the same thing as 4 over 1. So that means up 4, 1, 2, 3, 4 over 1. I don't have enough room on this graph to go 2 in an upward direction, so remember that you can always go the opposite. So that would be down 4, 1, 2, 3, 4, and to the left 1. And there is your line. And if you look, I obviously can't count because I put that one on the wrong spot. Sorry about that. Okay, so now I am going to, you need to use a straight edge. See, I can't draw a straight line without a straight edge. So make sure you use a straight edge. It's going to keep you from making mistakes on your solution. So there's my first line. My second equation, remember, just manipulate it. I already have a positive y on this side, so I am going to move or get rid of that x. And as long as I add x on the left side, I need to do it on the right. So I get a positive y is equal to x plus x is 2x minus 5. And so to graph this equation, it crosses my y at negative 5, and it has a slope of 2. So up 2 over 1, up 2 over 1, up 2 over 1, and bad example to give you because the solution does not land on this graph. Hold on, let me try that again. Okay, I found a different coordinate plane, but it's not showing real well, so you may consider just going up to the board and graphing this. It might make it a little bit easier. But real quick, if I graph these, for my first one, remember that it crossed at y is 1, very hard to see on here, but right there with a slope of 4, so 1, 2, 3, oops, sorry about that. And it won't let me take that away, so I'm going to say scratch that. How about you guys just do it on the board? When you get up to the board, you should see, and you can kind of see the trend right here. It's going to cross somewhere, you know, if I had drawn good lines, it's going to be somewhere down there. The solution is -3, -11. And then what you want to do is plug those in and make sure that they work. So plug in -3 for x. So that would be 2 times -3 minus 5. That's -6 minus 5, which is -11. So it checks out on that one. But to be a solution for both, it also has to, you need to plug it in for this one. So if you plug in -3 here, you get 4 times -3 minus y, which is, so minus -11, which is plus. So you get a -12 plus 11, which is -1. Sorry for the mess, but they do both work, so you know that this solution is accurate. Sorry about my graphs. Hopefully you guys were able to draw it up at the front. All right. I know you guys are asking yourself, but when in the world am I ever going to use this? Well, I've been very honest with you so far this year. Are you going to sit down and graph equations every day for the rest of your life? Maybe not. However, in certain situations, it might be the fastest way to solve a problem. So I'm going to give you, I'm actually stealing one of the problems out of the book that I think that you're going to do quite frequently during your lifetime. So I'm looking at number 34, and it's about choosing a cell phone plan, which you're all going to do. And you want to make sure that you choose a cell phone plan that costs you the least amount of money that fits your needs. So here's the situation. You know, of course, open up your book and look at it if you need to. I'm on page 364, number 34. And it says a cell phone provider offers a plan that costs $40 per month plus 20 cents per text message sent or received. They offer a different plan that costs $60 per month but offers unlimited text messaging. Well, depending on how many text messages you're going to send, one plan might be a lot better than the other. So you're going to want to figure it out. You're going to want to know, about how many text messages you're going to send per month. Now, some of you might be able to figure this out in your head, but remember that you can apply this to many situations in your life. You're going to run across numerous instances where you have a choice between 2 or 3 or 10 different products. And depending on your needs, you're going to want to know what is most cost effective for you. So anyway, the first plan is $40 per month. So you have to pay the $40 regardless. And then it costs 20 cents per text message. I'm going to call that M for message. Okay. Then your other plan is just $60 a month. And your text messages are free. So your text messages cost 0. Well, 0 times anything is just 0. So this is 60. And this is, again, I'm going to rewrite that. So it's 0.2m plus 40. The first question is, how many text messages would you have to send or receive in order for the plans to cost the same? Well, since they're going to cost the same, you could just set these two equal to each other. Now we want to know how many messages, so I want to solve for m. So subtract 40 on both sides. So you get 0.2m is equal to 20. Divide by 0.2. And 20 divided by 0.2 is 100. You can, if you can't do that in your head, just go off to the side and do it. But remember, right here, it's just a matter of moving the decimal. All right, so you'd have to send and receive 100 text messages for your bills to cost the same thing. The second question is, if you send or receive an average of 50 text messages each month, which plan would you choose and why? So you're going to send and receive less than 100 messages. So would it be smarter to go with this plan? We're going to call it plan 1 or plan 2. So you could go back in and plug in 50 messages and see which one is going to cost more or less. So if you plug in 50 messages for the top one, you would take, so you're plugging in 50 right here, if you take 0.2 times 50, your overall bill, this ends up being 10. So 40 plus 10 is equal to 50 bucks. This one, if you plug in 50, you don't pay anything for text messages, so you're still paying 60 bucks. Well, I would rather pay 50 bucks if I'm not going to use any more text messages than that. So you would want to go with plan 1. All right, next part. All right, 2 special things to consider when graphing equations. So remember that anytime that you graph 2 equations and they make the same line, it means that every single point on those 2 lines would be a solution. So if you graph 2 lines and they make the exact same line, it means that they have many, 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 many solutions that solve the system. So when they have the same line, you would say that it has an infinite number of solutions because the possibilities are endless. They go on forever and ever and ever. So then you have another situation where there's no solution, and if you graph 2 lines and they are parallel, it means that they never meet. And if 2 lines never meet, it means that they don't share a solution because they're never going to cross. And so parallel lines have no solution.